Northern California and swam and played water polo my whole life and have attempted to surf, but I'm really bad at it. It's really hard, so I have a lot of respect for surfers. And I recently read a book called The Wave by Susan Casey, and I just became fascinated by them. So this is sort of based off of that. Okay, so first of all, what is a wave? So it's a disturbance or variation. That's the most important part. And it transfers energy. So there can be lots of different types of waves, not just waves in the ocean. We know that there's P waves and S waves from learning about earthquakes. There's electromagnetic waves like gamma rays, which we just learned about also. Sound waves, radio waves, and then there are ocean waves, which is what I'm going to be talking about today. And these are the waves I find most fascinating. So how a swell is generated. So typically a swell is generated by wind. That's how it starts, but there's a couple other factors that affect the size of a wave. So what affects the size of a wave? The wind speed. So the greater the wind speed, the larger the wave will be. The wind duration. And these are all things that big wave surfers look for in waves and how they determine how big waves will be. The longer the wind blows, the larger the wave will be. Fetch, which is the greater the area the wind affects the wave, the larger the wave will be. Swell direction, so will the break be open to the current swell direction? The ocean floor, this is a big one. A swell coming straight up from deep sea onto a reef will generate big barreling waves, and a long shallow ledge up to the shore will slow down the waves and they'll lose their energy, causing the waves to have less speed. And then tide, so some spots are totally tide dependent. So how waves break on shore, we learned about this. The wavelengths, as they shorten, their height increase, their lengths decrease, and then they break on shore. And also waves can break offshore, tons of miles offshore. There's actually one wave, I think it's like a couple 100 miles off the coast of San Diego, that has been found by surfers, and it breaks in the middle of the ocean because there's an underwater volcano that it breaks onto. Okay, so basically waves are getting bigger and bigger because of climate change. So here's one quote from the book, The Wave. So average wave heights have risen by more than 25% between the 1960s and 1990s. And this also affects shipping and maritime disasters, huge surge in maritime disasters. So from 1990 to 1998 alone, 126 vessels were lost, along with more than 600 lives. And so now to the exciting part of the presentation.
Claire, real quickly, what part of climate change is making them be bigger?
What part of climate? Just the warming.
Just the warming.
The warming of the earth is making them bigger because it's just everything that has to do with the ocean, the currents, and
warmer water.
Warmer water makes
water.
bigger waves.
Okay.
Basically. So this is a quote from the book The Wave from big wave surfer Larry Hamilton about what it's like being inside a wave. So basically, what really stood out for me from this is just the sheer power of these enormous waves that people are insane enough to ride. So he stopped counting at 1,000 stitches, and he's broken every single one of his toes dozens of times, literally basically every limb in his body, and he still surfs them. So he's kind of insane. And so this is just to give you next kind of a, so this is a 10-foot wave. That's pretty big, that's pretty scary. I've attempted 3-foot waves before and I was terrified, so that's just 10 feet. That's not a big wave. There's a 20-foot wave, twice as big. That's a 30-foot wave. That's horrifying. People die on these waves. That's a 40-foot wave. Pretty ominous. I would say I think that's a mid-ocean break. So there's no shore here. This is just in the middle of the ocean. Pretty scary looking. That's a 50-foot wave. So this is what big wave surfers do. A kind of surfing called tow surfing was invented because before people couldn't propel themselves onto these waves because they could not swim fast enough to catch up with them because they're so fast and they move like 35 miles per hour. But Larry Hamilton and his crew in the early 90s developed a kind of surfing called tow surfing where they took jet skis and they basically hold on to a line at a jet ski, and then once they get right to the wave when it's going to break, their partners release them and they just shoot off onto this wave. And then there are monster waves. So the current world record for the largest wave is 90 plus feet. These waves, 10 years ago, they did not even think waves this big existed actually, that were surfable or even in the middle of the ocean. But they are getting this big, which is insane, which is great for big wave surfers, but not for everyone else. So this is a 90 plus foot wave. Like you can barely see this guy. This is Garrett McNamara. And this is in Portugal, and there's a video of this next. You're just gonna see how fast it goes. It's over in like 2 seconds. That's the toe surfing. So if he had fallen, he would have died. But he didn't fall, so.
Jesus.
Yeah, pretty insane. Alright. So yeah, that's Garrett McNamara. And then this is Laird Hamilton, and he is like considered the godfather of big wave surfing. He's like insane. They say most people ride these waves to survive, but when he rides them, he just like does it peacefully, and he has so much control. And this is a wave in Fiji called Chopu. So there's like a good like 20 or 30 big wave breaks in the world that these people have seeked out. These big wave surfers know so much about the ocean, and they know where to find waves that break. And so this is a really famous wave. It's called Chopu. I don't even know how that comes out of Teahupo, but that's how you pronounce it. And this picture is pretty much one of the most famous pictures and incidences in big wave surfing. It's from 2000. And this wave is like called the heaviest wave ever because of the way it breaks. If you look at it, it's just like insanely massive. It's like really thick, like behind it. It's not like a thin, skinny wave that just breaks over. And so next is an excerpt from a documentary called Riding Giants, which if you were impressed at all by that last little clip, like you should definitely watch it. It's an amazing documentary about big wave surfing. So this is about him on this wave and how it was really famous. Oh.
Mm-mm.
Where'd it go?
Mm-mm. Back up.
How'd I?
Maybe we didn't do automatic. Whoa!
Way up here.
Help.
Help. It's right here. Should I start from
Oh, there you are.
the... well, it's right there, so.
Which one?
It's that one right there.
This one? Riding?
Yeah. Right. So you can just play that and then go back to the problem.
I towed him onto this wave. It was to the point where I almost said, "Don't let go of the rope." And when I looked back, he was gone.
I think it's the single heaviest thing I've ever seen in surfing. What could be heavier than that?
Laird's wave at Chopu was the most amazing, single most significant ride in surfing history, more than any other ride. Because what it did is it completely restructured collectively our entire perception of what was possible.
You go through a surf magazine, you've seen Pipeline, you've seen Off the Wall, you've seen Waimea, you've seen everything, and none of it has any impact. But when that photo came out, it stopped everyone's heart, and they went, where and what is that?
I remember picking up that magazine, looking at that magazine and just going, man, that shit's impossible.
In my absolute prime, there's absolutely no way I could ride it.
Normally surfers are dragging this hand along the face. Laird had to drag his backhand, on the opposite side of his board to keep himself from getting sucked up in that hydraulic. You know, in the middle of that maelstrom, how did his mind say, this is what I have to do? No one had ever ridden as Laird rode on that wave before. And so it was the imagination of dealing with that unimaginable energy and coming up with the plan spontaneously. He couldn't practice.
Yeah, and then there's just like a few more slides.
I don't know what you
Oh,
did.
I did the right thing. It's just that one.
I think you better go with words.
Okay. Well, anyways, there's like 2 more slides left, and they're basically just pictures of shipping boats that had been pretty much demolished and overtaken by these huge rogue waves that are occurring in the ocean. There was one statistic I had. There was a boat called Discovery that went out into the ocean, and it was recording 50 to 60 foot waves out in the middle of this, yep, right here. And yeah, they spiked at 90 feet and higher, which they did not even know was possible. And there was just like a harrowing account of that. So here's some, you think of how large these giant, like the Titanic is, like that's how big these things are. And these waves are just completely coming over and crashing over the edge of these boats. So anyways, if you want to find out more about waves, definitely check out The Wave by Susan Casey, and then also Riding Giants, because it's really interesting and it'll make you feel very small and insignificant and unpowerful.
God.
Oh, questions? In the back. Questions?
You said that, like, after a certain point, they were out in the middle of the ocean. When did that start happening?
The waves?
Yeah, like, they get so big that they're out, like, they're away from shore completely.
Oh, well, it's not that. It's just that if you think of, like, the way that, I guess, the currents move through the ocean and swells move, it's that they're, like, rolling, and they don't break until they hit something that, like, forces them to break. And these, like, breaks that occur in the middle of the ocean happen because there's, like, an underwater, volcano or something. So there's, like, that break. I can't remember the name of it right now. They all have names, but it's like 100 miles off the shore of San Diego. And these guys will go out on jet skis like 100 miles offshore to just ride this one break, which is insane because if someone fell, there would be no medical attention that could be given to them. They're out in the middle of the ocean. So, yeah. Any other questions?
Okay, thank you. Sophie? I'll wait till you get down here because I think I'll just click on it, it's going to take off, right?
Well, I mean, you have to play, but yeah.
You ready? You advance or just place?
Recovery, or ISR. In open pit, the ore is excavated from a surface operation. Underground mining can take place shallow or deep within the earth, where the ore is brought to the surface. With in situ recovery, or ISR, in North America, water in a solution similar to carbonated water are injected into the ground to dissolve the uranium, which is highly soluble. The slurry is pumped to the surface through recovery wells and processed.
When performed correctly, ISR has low environmental impact and is the preferred method of uranium mining.
In the core, fission occurs and creates heat, which boils water and produces steam. The steam drives a turbine that in turn powers a generator, supplying grids and cities and towns with electricity.
The staff is hard at work disposing of intermediate level nuclear waste, half a mile beneath the Earth's surface, in a salt cavern. This nuclear waste must be isolated for tens of thousands of years. It's extremely dangerous. In 1999, the Wick disposal site opened, and the waste has been arriving steadily ever since. Everything is designed to make sure the waste gets here without incident, even the shipping containers.
Where is that
To
located?
undergo significant testing. The 2-pack 2 is dropped from about 30 feet in multiple configurations. After it's been dropped numerous times, it's put into an engulfing fire of jet fuel for about 30 minutes.
Once the waste is in place, the salt cavern will slowly close upon itself, crushing the barrels in less than 1,000 years, sealing them off completely.
Coldplay. All right, Sophie. Hot in that whole minute. Right here, you gotta get really scared now. And face your audience. There you go. No, don't hide behind the
Well, okay, yeah, that was my project on nuclear energy and disasters. There's a lot of pros and cons to nuclear energy, and it's a really controversial issue. But, I mean, the pros of nuclear energy is that it's already successful, like they've already developed the technology, it's clean, there's less CO2 emissions than like other non-renewable resources, but that's the key word, non-renewable resources. Uranium's non-renewable and it's gonna run out at some point, so it would be better to switch to renewable resources like wind power, solar power, hydroelectric, geothermal, biomass, like there's tons. And it's like that's all renewable energy, so we don't have to focus on like CO2 emissions because you don't really have that with like wind energy. Like granted, like windmills take up a lot of space, so that's another concern is like nuclear energy, like the nuclear plants only take up a certain, like a small amount of space and produce tons and tons of power, like produces 20% of the power in the US. But there are a lot of negative disadvantages to nuclear power. And like I showed you some of the effects of the Fukushima nuclear power plant, and it wasn't actually the earthquake that like destroyed it, it was the tsunami. The power plant was actually built to sustain earthquakes like that, but it wasn't built to sustain the tsunami that was that high. It was like 15 meters, I think, which that's like, I don't know how many feet that is.
35.
I was just say 32, so it was close.
Yeah.
But yeah, so it's a huge tsunami that hit it and knocked out the cores and.
What if it had been a 100-foot tsunami and they still built them by the ocean? Right?
Yeah, see, that's not a good idea. It's just a very bad idea, which is why we shouldn't promote nuclear energy. But yeah, and then the waste isolation pilot plant is for intermediate level waste, and which is like clothing, tools, equipment, stuff like that that's contaminated. And so that's what they're storing there. High level waste is it's like spent reactor fuel, and they haven't really figured out a whole lot to do with it. That was like in our lab, we had the Yucca Mountain they like showed why it wasn't a good idea. So like that was what they were trying to use, was Yucca Mountain. It didn't work, so they're trying to figure out something else now. And then like low level waste is like, I don't know, like syringes or like small tools that like get loaded, and they're usually stored on site, so it's not a big deal. And the waste isolation pilot plant is in southeastern New Mexico, in a desert, isolated from people, so can't really get there. That's about it. Any questions?
Your presentation for useful, it's on YouTube?
No, I could put it on YouTube.
You should definitely do that.
Anything else? Yeah.
What if they were switching from uranium to something else? You know about that?
No, I mean they're having like, there's research about like plutonium, I think, but like it's not, they're having some complications with it. It's not as like, because it's a man-made element, and so they're having, there's like, you have to produce it first and like make it, and then, so it's kind of difficult.
Thank you very much. One more question, go ahead.
Oh, sorry. He was talking about thorium. Thorium is like the transition one.
Okay.
And that, I was just going to ask about that, but.
Oh yeah, I didn't do too much research into
Right,
that.
okay.
I focused more on renewable energy sources.
Thanks. Thank you, Sophie. And Claire Richter? Ready to go? Advance here. Yep. And what you have. There we go.
Alright, so I'll try and be quick. So my presentation is on colony class disorder. So what is colony class disorder? A lot of people don't know what it is. The EPA defines it as a sudden, as these, all these conditions. Sudden loss of a colony's worker bee population with very few dead bees found near the colony. The queen and brood, the young, remain, and the colonies have relatively abundant honey and pollen reserves. So you need all of these to have colony class disorder. So this is a little different from like normal like diseases in honeybee hives, because usually you just find a bunch of dead bees outside the hive. Here, the bees actually individually go off and they die, not in big groups or anything. They just go away from the hive and they drop dead all by themselves. So this graph here is just, we had like years, and we just have like the number of colonies of honeybees, and you can see that they've drastically gone down in recent years. Colony class disorder. So again, what colony class disorder is not, it's not the big group of bees outside. So get that time. Why is this important? So honeybees are really important, not only because they pollinate flowers and make the world beautiful, but they pollinate a lot of our crops. Actually, 1/3 of the food that's on your dinner plate comes from food that is pollinated from honeybees. And if you can see, like a lot of these are vegetables and fruit. And you might say, okay, well, I don't really like vegetables anyway, so why would I care? They also pollinate a lot of crops that feed like cattle and other animals, like alfalfa. So that's a really big deal. You need honeybees basically to maintain what we consider a normal diet.
Just about all of it, really, from hay to corn.
Yeah. So what's a world without honeybees like? Well, it's already been seen actually. In Sichuan, China, this province in China, there are actually no bees because of pesticide use. And so the pear trees, agriculture is the main economy there, and so the pear trees still need to be pollinated. So what happens is the companies go out and they hire rural workers, and so they have thousands of people with little feather dusters and ladders, and they climb up these ladders and they take the feather duster and they take the pollen from one tree to another. This is ridiculously inefficient, and this is the type of thing, like, this could never happen in the United States because the cost of labor is so high. This is, it's ridiculous, and also it's a horrible job. Can you imagine doing that? And so what you have like 20 people doing, you have like what 2 hives can do. And it's just, it's way more.
If they tried importing bees?
I'll explain that in a second.
Okay.
So a history of colony collapse disorder in the United States. So it happened really in the winter of 2006 and 2007. 20 to 40% of the hives reported that they lost 30 to 90% of their hives. And so it doesn't seem too like a lot in percentages, but you can see in the millions of honeybee colonies that it really has significantly gone down since like the 1945s. And so 35 states have reported cases of colony collapse disorder, with the average loss being around 45%.
So it's a very steady loss, not just a single event.
Yeah, most definitely. And so colony collapse disorder, it's not just the United States, it's not just in China, it's throughout the world, especially in agricultural regions. And I mean, these are just places that have reported colony collapse disorder. There's also a lot of research being done in the United States, Great Britain, and France. So what causes colony collapse disorder? There's a lot of possible hypotheses. As you can see by this picture, it's kind of like a lot of things going on, a lot of things could be the reason. They could all combine and be a reason, because we're kind of doing a lot to our world with pesticides and different things like that. So the different hypotheses are, first of all, that we're moving honeybees around so much. Varroa and tracheal mites, that we're feeding them corn syrup, pesticides that actually affect the corn syrup, and the bees themselves directly, a fungus, and like a combination of these things. So moving honeybees. We move honeybees around a lot, actually. As you can see, we move them around because there's increasing demand for high crop yields because we want cheaper food, we want more food, therefore there's higher need for pollinators. And actually, I don't know if you remember from the past slide, almond groves require honeybees. They can't pollinate by wind or anything like that. They need honeybees, that's it. So these almond groves are in Southern California. So 300,000 hives every year are transported from North and South Dakota to Southern California. So I don't know, it's actually pretty impressive. I've seen one of these. They're these big, huge semis, and they're covered with hives. And there's like these big meshes over them, and you can see all these like bees like buzzing between the mesh. It's pretty impressive. And so bringing hives from North Dakota and South Dakota to Southern California, that spreads diseases, but it's within the United States, so it's okay. But the thing was, in 2005, almond growers in California requested that honeybees be imported from Australia. Now, prior to 2005, it was illegal to do this because they wanted to limit the spread of diseases. If you remember from before, colony collapse disorder happened in 2006. So this could be a connection there of bringing more diseases. So there's also Varroa and tracheal mites. So this is connected to the whole disease thing because they make bees more susceptible to diseases. So they transmit bee viruses like the Israeli acute paralysis virus and the Kashmir virus that have greatly affected bees, especially in those regions, and killing a lot of bees. So the Varroa mites, they destroy the comb by leaving their feces, and it like ferments the cell. And they also attach the bee skeleton, as you can see. There's a little mite there on the bee body. And there's also tracheal mites that attack internally. So just a quick thing on Varroa mites. So what happens is they come in while the bee larva is growing, and so they suck the blood basically of the bee while he's living and can transmit diseases. And they also leave with the bee when the bee's fully grown and continue feeding the bee. So the reason, one of the reasons perhaps that Varroa mites are existing and have become more of a problem is because, I don't know if you can see this little picture, but the industrial made comb for honeybees is a tiny bit larger by like 0.5 millimeters, sorry it's so small, than like your natural honeybee hive. So that tiny bit of space allows the little mite to go down and touch the bee. So another big thing is beekeepers feed corn syrup to the bees. The beekeepers do this, and they also feed them regular sugar, like table sugar, to help bees out, especially during winter, like when it's harder, when there's not as many flowers for the bees to pollinate. And this is really common, especially if you have like industrial hives. There's only so many flowers, and if you're in the winter and you don't have that much, you need to give it to them. So beekeepers have been doing this for years, and it's been fine. The only thing is, corn syrup now comes, where it's coming from corn with a certain pesticide, which I'll talk about in a second. But corn syrup, when it's warm, it forms HMF, and if you feed bees just HMF with at least within like a sugar water that's at least 100 parts per million, they'll actually die within 25 days. So what this graph is showing is just the amount of HMF and how many parts per million you have required for death. And the ironic thing is, we eat corn syrup too. So if honeybees are dying, what could this be doing to us as well? Another thing that could be killing honeybees is a fungus having in the bee gut. And this guy in Shank saw that every colony with this fungus and survey died. And so they suggest antifungal agents, but they're not so sure why bees would leave the hive to thrive with colony collapse disorder, so this is like a less popular theory of colony collapse disorder. And then, so the pesticide I was talking about before, neonicotinoids, was first used, it was an insecticide first used in the 1990s, and it's now exceedingly popular, and almost all the corn in the United States is treated with it. And so this is the corn syrup thing. So the corn that is grown with this pesticide and makes the corn syrup is what's killing the bees. So experiments in France and England have proved this, and it shows that the pesticide makes so that the bees lose their homing device, so they can't get back to their hive. And so what is being done, the primary thing as I've been showing, is research. Pesticides are also being sprayed at night, which is a really good thing because in places like southern Arizona where the orange grows, they spray at night and it affects the bees a lot less because the bees are only active during the day. And the biggest thing is definitely to spread the word because not a lot of people know about colony collapse disorder, and we want to save our bees if we want to continue with having our diet.
Thank you.
Questions?
Come across me recently, I remember reading something about how cell phone usage can cause bees to collapse.
I'm not so sure. I didn't come across any of that. I'm not really sure why that would hurt them. Yeah, because I mean, I don't think it would really kill them.
But then where does the research start? So I don't know.
Okay, yeah. I mean, I don't know. Sorry.
How did you come to this topic? Is it a really interesting topic?
Yeah, I'm actually doing research this summer on honeybees, so.
Cool. Here?
No, back home. Minnesota.
Thank you very much. Claire? Okay, Sarah Legman? All right. Let's see.
Alright, so I did my presentation on overconsumption and how this is harming the environment. So just a quick overview on consumption. As I'm sure we all know, it's been rising steadily in almost everywhere in the world. And this is due to many reasons, which I'm going to mention in a minute. But two notable ones is increasing population, more people obviously demand more, and an increase in prosperity, which in turn leads to increased purchasing power. Another consumption driver is production. Since the Industrial Revolution, we've actually experienced an enormous increase in our production efficiency, and this is due mainly to two things, technological innovation and cheap energy. Just an interesting fact I found, Modern industrial workers produce in 1 week what 18th century workers took 4.
Oh, I don't know how that happened. Yeah, there you go. So just hit the right button.
Okay, got it. What 18th century workers took 4 years to produce, which is kind of crazy, puts things in perspective a little bit. Another consumption driver is advertising. This is actually one of the most effective tools, and businesses and corporations are very much aware of this. As you can see in this graph over here, the amount of money that goes into advertising has increased exponentially over the years. A lot of what we're exposed to are advertisements. Half of the space in the average newspaper, half of the mail we receive, and a quarter of network television programming. And then that's just a creepy picture I found online. Some miscellaneous consumption drivers real quick are government policies. An example is since World War II, the United States government has been subsidizing suburban home building. So this is a graph of how house size has increased over the years. With increasing house sizes, we experienced an increase in energy for cooling or heating, water usage, increased electricity usage, and then obviously just increased resource extraction to build the house in general. The last consumption driver I'm going to talk about is the introduction of the credit card. Kind of the way an increase in prosperity leads to increased purchasing power, I think the credit card works in the same way, because people can now buy things that they wouldn't have purchased before with money that they don't currently have. So how is this affecting our environment? Trends indicate that resource use and consumption are contributing to ecosystem deterioration, and this is not sustainable because we have a finite amount of resources on the planet, and we're actually consuming more resources than our planet can regenerate. So what this means is that future generations are not going to be able to live the quality of life that we live now. And that's just more detail on the effects of so we're consuming a lot, it's affecting the environment, yada yada yada, why should we care? Like I said earlier, we're deteriorating our ecosystems, and these ecosystem services are actually extremely important to human well-being. This is something I found out this semester actually, that we get aspirin from willow tree bark. So if we continue consuming the way that we do, it can lead to habitat destruction, which leads to loss in biodiversity, which is actually something that is really important because there's really good genetic knowledge that we can gain from biodiversity, and there are a lot of cures that we don't know yet, and if we do lose this specific species, we may never find them. And then just anti-ovarian cancer drug comes from the yew tree. The anti-leukemia drug comes from the plant called rosy periwinkle. And then that's just a cute frog. We don't want to go extinct. So like I mentioned earlier, all of this has a direct feedback to us. What we do to the environment indirectly comes back to affect us. And this is because the ecosystem is very complex, and there's a lot of interdependencies within the ecosystem. So any small change that we've could result in really big unexpected outcomes that we're not yet aware of. This is just a quick example that Professor Cleveland in the geography department actually did a study on bats in Texas, and they provide really important pest control services, such as, so they reduce the need for pesticides, which increases food security for us, and then no pesticides obviously are better for the environment. Those are just a couple of numerical values, like their economic value. And then this is also just some facts that we'll look at later. This is a map of the areas in the world that are undergoing land cover change. And This is an illustration of the benefits that we get from our forests. Obviously, there are more than just the wood that we use for paper and building homes, etc. We get other benefits like recreation and hunting, watershed protection, and grazing for other animals. So overconsumption is harming us, but it's also harming other things in the environment. So what is being done? There's actually a lot of things that are being done to curb our consumption, or at least make it a little bit more sustainable. One of the things that I'm going to talk about are eco-labels, which are present in a lot of sectors. This is the Marine Stewardship Council, and they promote sustainable fishing. The fishery sector is actually a really big problem in the environment now because, as you can see over here, we are harvesting or catching a lot of fish, and it's not sustainable, and we're depleting our fish stocks. Same with the forest steward. I don't know why FOR is capitalized, but same with this. Promoting responsible management of world's forests. You can read over this later if you're interested. And this is actually something I wanted to talk about real quick. I learned about the degrowth movement in my sustainable development class this semester, and it actually began in France. And contrary to what the name implies, it's not just about decreasing production and consumption. It actually advocates just a fundamental change in the way we think and a sort of escape from the economy. Degrowth advocates view society as too materialistic, and a couple of things that they propose, which I don't really think many of us would agree with, is a reduction in work week hours and a reduction in pay, because they believe that this will create more time for spending with your family or recreational activities, and then ultimately just less money for consumption for things that aren't really necessary. And then, can it be done? Obviously, this is a really big change that needs to happen and probably will not happen in our lifetime. I don't know, it might be cool. But it'll require a lot of policy reform and just kind of another look at how we view the economy. And I think a major thing that needs to change is our social and cultural norms. Because we have things like Black Friday and Cyber Monday and like retail therapy, and all of this is just kind of pushing us to consume more when we really don't need. We don't really need the latest fashion or clothing or the newest version of the iPhone, which comes out like every 6 months or something absurd like that. And I think just in general, we need to kind of separate the notion that consumption can lead to happiness. And then, yeah, it's just a picture I also found online. Don't do anything, need to lot less. And that's it.
Thank you. All right, Sarah. Stand out front, bold. Question here?
If the economy and people that want to do the economy are always telling us to buy things, and the environment is telling us not to buy things, what are we supposed to do?
I mean, obviously we have to buy things in order to like basic needs in order to survive, but I think in terms of overconsumption, the problem is more that we're purchasing things that we don't really need. Like electronics, for example, I think that the fact that they come out with a new version of everything every year isn't necessary. Like I feel like you don't really need like the iPhone that looks a little bit different and does one thing extra. So I think that like we need to consume obviously for like for the economy to like keep going and just for us to live. But I think it's the unnecessary consumption that's the problem.
Just to add to that question, I feel like also the way you can merge it is that the products are more sustainable.
Yeah.
Where, like you mentioned, new PowerPoint several times, where totally consumed, but also like with the marine staff, it's sustainable for public environment and the economy.
Yeah.
Yeah, I feel like it's more of a construction problem. Like they tell us to consume things, and you probably used to point about consumption, but that's because the economy is built on consumption. So what really needs to happen is the economy needs to shift to something that responds to people not buying so much all the time.
Yeah.
So really,
which is hard.
Yeah.
Thank you. Okay, Danielle. One more, just won't take long.
Alright, mine's just a video, so it's on water bottles and like production and consumption.
This is really cool. I found it very moving. That's amazing. Wow. Look at all those references. It's not like she went out and found a movie, she made a movie. Today's presentations have all been amazing. Questions now for Danielle? Up there.
That's Aquarium by No Such Thing. Yeah.
And I went to your liquor store.
Our
Hardware store. Sorry, he's mistaken. All right, thank you very much, all of the speakers today. Thank you.